Hey, good morning to everybody. Now listen up. If you're a hybrid and electric vehicle technician, I'm pretty sure you recognize this very easy. This is an inverter assembly that belongs to 2013 Toyota Prius. Hi, welcome to this new episode. But this one, in this case, is going to be very, very interesting because we're working on this inverter that triggers us the code p0a94 that describes very clearly DC to DC converter performance. Now, we already diagnosed this vehicle last week. Actually, I've been trying to shoot this video for some time, but it's very interesting what we found, and I want to share with you exactly what happens when a Toyota hybrid vehicle triggers p0a94. Now, let's take this inverter apart and let's see what happens. So, if you want to learn, stick around and then we will continue it. Alright, so before understanding diagnostic trouble code p0a94 that stands for DC to DC converter performance, we need to understand what in the world is this component, which, as you can see, is not a small component, it's actually very big. But in my channel, one of my first videos, I had a series about the Nissan e-power technology where we completely took apart an inverter assembly of the, once again, Nissan e-power, the latest hybrid technology for Nissan vehicles. So here's what you need to know. Every single hybrid and electric vehicle, you have to remember that it's a combination of technology, okay? One internal combustion engine and one electric motor, but you need some component in order to control that electric motor, because the problem is high voltage battery can only store DC power, okay? But the thing is that the electric motors, those are big, giant, powerful permanent magnet motor that works with three-phase alternating current, or AC. Who does that? Who does that conversion? Well, this exact component, this very component. So this is called, in Toyota you might call it the inverter with converter. Obviously when it comes to converters, because that's the DC to DC converter. But if you understand what is the diagnostic trouble code, p0a94 just stands for DC to DC converter performance, okay? DC to DC converter in the diagnostic scan tool description refers the inverter, all right? So you don't want to get confused about that. Okay, so what we're gonna do, we're gonna open this inverter, we're gonna inspect all this component, and let's see what finds. What are we going to find once we take out this inverter assembly that triggers p0a94? Because when it says, wait a minute, performance, but what is that performance? But this is just an electrical component. Well, let's open it up and let's see what's going on. I'm going to show you step by step. I will try to make this as quick as possible, not so boring, because obviously this is a very, very sophisticated piece of equipment. However, if you don't understand what it does and how to properly take care of them, even preventive maintenance when it comes to the cooling system, super important, then yes, this inverter can go bad, and finally it's going to trigger p0a94. That actually, it is a very common issue that happens to Toyota hybrids over time. Okay, so let's open it up and let's see what we find. We will continue. Well, so the inverter assembly receives, of course, the direct current or DC current from the high voltage battery through this huge connection that, as you can see over here, is where you connect and disconnect positive and negative from the battery. As well, as you can see, it has a small little interlock over here. The interlock, you have to remember that the interlock is, as soon as you unplug this, the serial interlocks tells the computer that if by chance you're going to start it, it will never start, because this interlock is just a safety feature. All right, so stick around. Okay, so we understand the inlet from the battery. Okay, we also have a positive and negative DC connection right next to it, but this one belongs to the air conditioning compressor. Another tip, you have to remember that Toyota hybrid vehicles, they use an high voltage electric compressor. All right, so she needs to gather the power from somewhere. Well, this is also the power distribution. It receives positive and negative from the battery and sends this right here to this DC connection directly to the AC compressor. All right, we will continue. All right, and next we have this power fuse, because if by chance your AC compressor goes bad, shorts, whatever, because remember it's an electrical external electrical component directly attached to the inverter. So in order to not damage the other components, well, it has its own fuse right here. So if the fuse blown by chance, no problem, you can still drive the vehicle. All right, that's one thing. But then one of the other issues is, well, DC power, but then the electric motor, you have to remember they work with 3-phase. Well, these are your 3-phase outlets to control the electric motor. Name in right here: V1, U1, W1, and V2, U2, and W2. That means that this one is the controller outlet for MG1, and this one is the controller outlet for the MG2. The power for the electric motor comes from these two outlets. All right, once again, MG1 and MG2. But then, if the inverter assembly, once again, why do we call it an inverter? Well, because it does the inversion from DC to AC and vice versa. Because remember, if you use regenerative braking system, of course you will turn AC into DC. That's why this is very complex and does all the conversion. That's why it's called probably DC to DC converter, or just let's just call it an inverter. However, once again, diagnostic trouble code p0a94. DC to DC converter performance just refers about the DC to DC as the inverter as a complete unit. Okay, let's continue. One other component that we have over here is this one. Well, hybrid and electric vehicles do not use alternator. They use the DC to DC converter that steps down the high voltage DC into low voltage DC. Okay, in other words, a step down voltage unit. So steps down high voltage DC to low voltage. Now this low voltage outlet is supposed to be like your alternator outlet power. This is exactly what it does. Why? Well, because this unit is the one who's going to fit with power all the onboard electrical system, computers, and everything related to the vehicle's electrical system. Because remember, the vehicle electrical system don't work with high voltage. Okay, so DC to DC converter steps down high voltage DC into low voltage DC. I don't want to get confused, you two guys, but I'm trying to be as more specific as I can. So let's continue. All right, so our low voltage outlet, of course, ground will be chassis. And then look what we have over here. We have 1 and 2. So this is inlet and outlet coolant that circulates inside, because inside this unit there are a bunch of big transistor or bipolar transistors that are the very components that makes the conversion from DC to AC and AC to DC and vice versa. So because that conversion takes a lot of power, it produces a lot of heat as well, and it needs to be cooled down. And somewhere around those components is the failure that causes this inverter to fail at the very end. Now the problem with this one specifically was that just it overheat because it had sadly had a coolant leak in the hybrid system cooling. So once again, the hybrid system coolant is extremely important because your electric motor depends on it, and then of course the inverter assembly depends on it as well. So no more wasting time. Let's open up, let's see what we got here. We will continue. So the first thing I'm gonna do, obviously I have to take out all this covers to take out the main cover. But before that, I'm gonna take this is the controllers, the power electronics, communication with the rest of the vehicle, all the controllers, all the rest of the computers, everything. And let's open this black little cap and this one, because we need to disconnect all the electronics from the main capacitor that is connected right here. So let me just open it up and we will continue. All the bolts are out. So this one is the main seal of the power electronics and communication lines from the low voltage system. All right, so I will put this apart. The next thing, I already took all this from this side, but before taking it out, you need to disconnect these 3 bolts that connect the capacitor to the power electronics below, whether it's IGBT or the DC to DC converter, as well as this connection over here. All right, so they're off. This is ready to go out. But don't you think this goes out as this easy? This is actually very well sealed with silicone, so it takes a little time to primer out. You have to be very careful and take your time because it's actually a little delicate. But once you free everything, this goes out as a complete unit. All right, so let's explore what we got here. We'll continue. Now that we took off everything, okay, let's see from inside. And there you go. And we got over here, this is the main capacitor. So the thing about the capacitor is because you need to filter and smooth the power coming from the high voltage battery back and forth. Even these 2 cables that goes directly, let me show you, inside the transistors unit. So definitely all these signals need to be very filtered and smooth. All right, so that's the reason for all these hybrid and electric vehicles, they use a huge capacitor. And the other thing is the protocol to shut down a vehicle, the vehicle needs to discharge this capacitor, otherwise it's too dangerous. Well, you have over here the discharge resistor. Once you turn off the vehicle, this resistor discharges the capacitor and it is completely safe. However, you still have to follow the safety protocols when you open in any component that's related to the high voltage system, because if by chance this discharge resistor fails, you could get shocked. So that is the reason why every time you're going to touch every single component related to the high voltage system, you have to measure and make sure that there's no voltage on it. The reason is this huge capacitor can do very, very harm if you touch both polarities. Okay, so we will continue. So we're done with the capacitor. So this is the naked inverter assembly. We are just gonna need to disconnect all this bunch of components. Okay, we have over here, as I said, these are the electric motors outlet. The motor generator number 1, remember, is the starter generator and the CVT ratio, and then of course MG2. MG2 is the one who really drives the vehicle. So both electric motors with one single unit control. Okay, positive and negative from the battery, and the outlet for the AC compressor. The cooling system, as you can see, power electronics. Now we have a lot to take apart over here, so let me just begin to take these out. I have to take out this controller board. I don't really want to bore you with all this, so let me just disconnect all this. Just a bunch of electrical connections over here, not really such impossible thing. Let me take out first of all these unit over here. Let me take it out and I'll show you what it is. So 1, 2, 3, 4, and 5, 6. Just a moment. I want to do it right here live with you guys. We can actually take out this unit, but then as you can see, what it does Can you see it hooks the main power lines for the electric motor? Well, this unit is a Hall effect current sensor. Every single component that receives or delivers power, how in the world you think the computer is going to read what's going on? Well, you need a Hall effect current sensor in order to read the inlet and outlet current flow. Okay, so after removing 1, 2, 3 and 4 8mm, of course disconnecting all the electronics, I can take out the main controller. Oh, wait a minute, I forgot this gentleman over here. Sorry. You see, there she is, she's out. All right, that's it. So the main communication board and control, it's out. Let me just put it over here. All right, now we have this main board, that this is finally the controls for the transistors. But in order to take it out, this comes out as a complete unit. So let me take it out as a complete unit and we will inspect it outside, okay? But because I already diagnosed this, we did it last week in school, I had to open this up. However, I'm using this just for educational purposes. But the only way to take these out and check the transistors, you have to completely unsolder each one of the pins for the transistor, and it uses like 100 pins, so it takes a lot of time. I didn't do that because I'm gonna keep this as for educational purpose. I just cut it, but it is a replaceable component, but you won't find it as good as new. Okay, it's just better when this gives trouble. It's just better to replace it. But the main purpose of this video is we want to see what happens inside the inverter that damages. So let me take it out and we will. So the main controller for the transistor is this board, and these are the power signals that triggers the transistors to work. Every single one of them you have to unsolder to take out this board. I didn't do that, I just cut it, because remember, this is in bad condition. And I just want to show you what's really going on. So let me just take out these 4 small little bolts from here, and let me take out the board. We will continue. Now listen up, before taking it out, I already did a full inspection of the board, and absolutely no capacitors, no diodes, none of the chips, everything looking fine, which means the electronic controller is fine. Okay, so let me take it out. All right, so each one of these pins is the one that goes directly to the transistor case. Okay, so let me take these out, and I will have to take 1, 2, 3 and 4. Just give me a second. So then now, if this unit receives the power through these pins over here, okay, and then the outlet, it's 2 outlets of 3-phase, that means inside over here has to be the transistor. But of course there's a lot of fingerprints over here because we're already touching it. But look at this mark, it's like a burning mark over here. Let me open it up. See, oh, sorry, I'm missing one. Let me continue, let me take this out. We'll continue. Okay, can you see this burning marks over here? Okay, now let me take it out. All right. Bunch of sticky material there, like an insulation protector over here. And take a look at what we got here. This is what I consider one of the most beautiful things in the hybrid and electric vehicle, which are the transistors. These are the IGBT, or we can just call them insulated gateway bipolar transistors. Once again, they receive the power, and through all these transistors What is a transistor? Well, the transistor, let's say, is some sort of a switch, but the problem with the switch is that a very, very high speed switch. We're talking about thousands of times switching per second. Well, that's exactly what happens to this transistor. But let me show you exactly what happened over here. All right, so the transistor is protected by this thermal gel, right? As you can see, this transistor protected by thermal gel are one of the most efficient. But let's look over here at the very end. Yep, we sadly have a blown IGBT. We have 1, 2, and 3 IGBTs completely blown out. Now, what is the reason that this happened? Well, most of the time is because overheating. Once again, it receives the signal to excite this unit and finally conduct high power from this DC and turn this into a very high frequency AC. Okay, transistor. This is exactly what they do. All right. Let me show you. But I want this one over here kind of like begin to blow. Let me see. It's very difficult to focus. Yeah, very difficult to focus. But anyway, now this one is a completely blown IGBT, but what I want to do is, let me take out the thermal gel and see exactly where it burned out. Oh, there it is. So the pins inside the transistors completely burned out. Yeah. Of course, you cannot replace this. This IGBT unit comes as a complete unit, so you sadly won't be able to replace it. The thing is that this just receives low voltage signal at a very, very super high frequency. Okay, once again, thousands of times per second switching in order to turn DC into AC, alternating current. Okay, now that is a way much more big complex system, because it works with PW and pulse width modulation. But I don't want to bore you guys with this. The important thing is that the DC to DC converter performance, or the inverter performance triggered by diagnostic trouble code p0a94, means that there's no performance, okay, because she's not doing the job. She's receiving the signal, but it's not doing the job because it's burned out. This is literally what happens to the inverter assembly when overheats. That's one of the most common issues that happen very, very much. So let me know what you think about this. If you're liking this video, hit that button, like and subscribe. Remember, you gotta support the channel. So what are we gonna do? I'm gonna take out the unit, let's say from below, from its cooling pass. All right, guys, we're almost done. Okay, so as you can see, I already opened the, let me show you. Okay, I took off all the thermal gel, and you see that the main connecting pins completely burn out. Now, it's not about them shorting between them, because remember, this is just one single connection with many pins in parallel. What happened is they couldn't stand anymore the current flow. It's like the very same thing as a burning fuse. Well, it happens exactly the very same thing. Now, why does this happen? Well, if you have, for example, a cable with a current flow with a lot of resistance, or begins to overheat for some reason, okay, finally that cable is going to cease, it's going to burn out. Well, that is exactly what happened to this semiconductor, or IGBT, or transistor, whatever you want to call it. But remember, it's bipolar transistor. So, okay, give me a second. So this is basically what happens. Now, if you compare this switch, for example, to this one, they are very similar, just a little smaller. Okay, the main pins completely blown as a fuse. Okay, well, obviously this is gonna cost that there's not gonna be any more inversion anymore, especially to the DC to DC converter, or neither of the power electronics that needs to convert DC to AC and AC to DC, vice versa. Once again, this is not serviceable, so this is just for educational purposes, for you to understand how these units work. Now below this, I already took it out, let me show you. Yes, second, you can clearly extract this, and you can see this is the small little cooling device. You see, coolant flows in here and has an outlet. If by chance this begins to overheat, well, the transistors will overheat and finally burn out, and then your inverter is bye-bye. So this is a complete replacement. Okay. Let me show you one more thing. All right, and then we got over here the capacitors for the DC to DC converter, and as well as the reactor, the transformer that steps up the voltage. Because you have to remember, Toyota Prius works a little different. The electric motors are not so big and the voltage is not so high. But then this unit has a reactor transformer that steps up the voltage from 201.6 to 500, almost 600 volts AC, in order for you to drive the vehicle with a lot of voltage with a low voltage source. Okay, so it's a very nice, a very complex, but basically because it's too forced out, well, it ran out of liquid. Bye-bye inverter. And what really damages is the IGBTs. So the IGBTs, there are very, very few videos about this in the internet, but you have it now here at Hybrid Solution Diagnostic. Diagnostic trouble code p0a94. DC to DC converter performance, it's most of the time it's just a blown IGBT, and that's it. Once that happens, just replace your unit and that should fix your problem. Now make sure, because most of the time the reason is because it's overheating. What happens, so the coolant and the small little plastic water pump in the inverter, you have to make sure it works properly, right? We have now a new TikTok in our social media. Follow it, because I'm giving great everyday tips on the TikTok. Follow the Instagram, follow the Facebook page, and don't you damn worry, I have tons of great more content coming here. So thank you so much for watching. I see you guys in the very next episode. Bye. Do you guys really think I was gonna let you go without seeing the true DC to DC converter on the bottom of the inverter? You got it wrong. So let me show you. Okay, so this is the bottom of the inverter assembly. So once we already took out this cover, which actually it doesn't come out very easy. It's very well sealed. Now the reason is because this one is actually the real DC to DC converter that receives negative and positive directly from the battery, all right? And then this high voltage DC passes through a small transistors over here under this board that are, you won't be able to see it from here, that are also cooled by the same housing. And finally it is passes through this coil to be filtered and smooth, rectified through a bunch of diodes, and finally is going to deliver us DC low voltage 14 volts. So then you can say that this one is what substitutes completely the alternator. This is how it works. But the other component we have over here, let me show you. The main transformer, this is the reactor. So the reactor receives the power as well directly from the high voltage battery and steps up the voltage to finally deliver, all right, high voltage DC to the inverter, and the inverter, instead of receiving 201.6 volts from the battery, this transformer turns those 201.6 volts into almost 600 volts by just stepping up the voltage with this coil unit. Very nice, right? So this is what we could say a full exploration deep inside the Toyota hybrid system inverter with converter. Okay, that comes with, of course, a reactor, a group of set of insulated bipolar gateway transistors, and then of course the DC to DC converter in order to run the vehicle's electronics. Now, thank you so much for watching. I hope you guys like this video. I'll see you then.